Hello and happy February, everybody. This is John Greiner with Basin Safety Consulting and Training. This month we're going to be covering a few topics and a lot of regulations, but I promise to keep it short and succinct and focus on the highest level and most important points. So this is fire extinguisher and safety use, as well as emergency response plans. All right, our agenda, we're going to be covering a little bit of fire science, again at the basic level, fire classification and prevention. We're going to talk about hot work permits and fire watch requirements, NFPA symbols regarding chemicals, some site-specific safety information, training requirements for fire extinguishers themselves, including use and proper strategy for extinguishing a fire, where to place them, exit routes and requirements, and lastly, emergency response and exits. So we're going to be covering, again, a lot of stuff, but again, we're going to kind of merge it all together and keep it simple. So there are four elements of a fire. We have fuel, oxygen, heat, and in the last 10 or 15 years, they included the chemical chain reaction as a part of the process. And essentially, that's when, whether it's a solid or a liquid, changes from solid or liquid to vapor, and it's the vapor that ignites. It's not the actual liquid. Even if it's gasoline, the gasoline itself is not igniting. It's the vapor being released as the temperature of the gasoline increases. So the warmer it gets, the faster the vapor from the gasoline is released. And then if that's what's igniting and then creating heat around that liquid, then it's going to release even faster. And obviously there's a point at which if there's enough vapor, then you're going to get an explosion because it's literally hot enough to combust everything. So we do need that heat, and then oxygen obviously is necessary at some mixture in order for ignition to occur. And then lastly, you have your fuel, whether it's wood or gasoline as an example, or anything. So as far as the different classifications as far as fuel are concerned and types of fire, there's 5 different types. You have A, which is anything that turns to ash. You have Class B, which is liquids such as gasoline, again, kerosene, paint, blah, 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 propane. That's anything that has a boiling point. So your liquids have a boiling point. Therefore, just remember, Class B is a liquid fire. C is anything that has a charge or current, such as electrical equipment. So we have a charge and current going through those. Different type of fire. So again, its own classification of fire. D is anything that dents. So combustible metals, because metals dent, such as magnesium, titanium, potassium, sodium. All these are in the D category of fires. And lastly, we have Class K, which is kitchen fires. So these fires are a little bit different in composition as well as extinguishing, and so just keep that in mind. All right, so Class A fires, breaking this down real quick, anything that turns to ash. So paper, wood, some plastics and rubbers, cardboard, basically anything that's going to ignite. Most building materials are in Class A fire. Rags would be considered a Class A fire, but an oily rag, see, that would be an A, B fire because, oil is a petroleum product. So, one thing we definitely recommend with, anything that's oily or saturated, because it can, if there's enough of it and some ambient temperature, it can actually increase that temperature, within the material. So, because rags get hot, and can be enough to ignite. So definitely, dispose of those appropriately, put them in, waste bins that are designed for that. Class B fires, some issues here is refueling gasoline-powered equipment in confined spaces or really transferring flammable materials inside of a confined space, having open flames nearby, having something that can spark, having non-intrinsically safe tools, etc. All these are going to create Class B fires. So, oil, again, propane, NGL, condensate, all these materials would be in the Class B type of fire. So C, okay, so a lot of ways to prevent electrical fires. A lot of the fires that we're seeing recently in the area are electrical fires. A lot of times if you're drawing too much power, you got too much amperage going through a system, that's going to usually trip a breaker. But if there's damage to a cord, and we've covered this before, and it's not hooked up to a GFCI, then obviously energy can transfer from the power system to something else. And if heat comes with that energy, which it usually does, and there's a flammable atmosphere, then you're going to have a fire. Now, a lot of these fires too, they can start in the incipient stage as one type of fire and then change. So for example, class B, right? You got a little gasoline, you light it on fire, there's paper nearby, now it's an AB fire. So they can change and then grow. That's why most fire extinguishers that we use out here in oil and gas are A, B, and C combined. Type D extinguishers, we're not dealing with typically in this region on a consistent basis. But, if you're working with magnesium, etc., the best thing to do is look at the SDS, and it's going to give you the firefighting measures. And 9 times out of 10, honestly, with Class D type fires, the right answer, the solution is walk away. Like we're not putting this thing out. It's going to take fire trucks and fire trucks and fire trucks. So this little extinguisher I'm holding in my hand is not going to do anything. Class K kitchen fires. The big issue with the kitchen fire is that grease will ignite. You'll put it out, that heat source will still be there, and then it will continue to smolder and then reignite itself. So that's basically the type K is a little bit like a petroleum product, and then it coats the material, and then it doesn't allow reignition because it prevents oxygen from coming into contact with the media. All right, so hot topic, pardon the pun there, hot work permits. Hot work is considered any work that creates a heat source within a range of an ignition source. So, once again, natural gas, oil, vapor, even production water, salt water. There was an incident in Newtown about 2 months ago, and end of 2021, where a welder was welding on a water truck, on the frame of a water truck, and there was some vapor leaking out of the tank. It ignited, and the welder passed away. There was a mechanic working on the truck itself. He passed away, and then 5 other people were injured from inside of the building. So it was in a shop, and then there were people in the office, and they had to be transported to the hospital. So, hot work permits and permitting is really where you determine, hey, there's a possibility of a flammable atmosphere being created by whatever it is that we're working with. So what we're going to do is we're going to do some testing of that and make sure that there's no possibility that welding or cutting or brazing or drilling can ignite flammable atmospheres. So you need a gas detector for that. And a permit, if you follow that permit, it takes you down step by step, different things you need to look at. So the other thing about hot work to remember is that there is a distance requirement for doing that work around a potential ignition source. So typically you're looking at 35 feet horizontally from the work site. And if you can't move, there's different things you can do to protect using fire retardant covers, ventilation, etc., guards, curtains, and that's what the permit kind of walks you through. So typically if you're doing any of this type of work, you will need a permit. Brazing, cutting, grinding, soldering, thawing pipe, torch applied, really anything torch applied, and then also welding. So we do see that people use torches to thaw valves, etc., on production systems, and that can ignite things. Even methanol, a lot of people in the field in the wintertime here, they use methanol for stuff. But you can overfill tanks, and you can overfill materials with methanol and typically tanks, and then create a very combustible atmosphere where it wouldn't usually ignite, but it will because it's overwhelmed with methanol. So for hot work permits, they need to be typically signed by a competent person that's reviewed it. You're going to have job number, et cetera, where you're at. Are you working around combustible materials or flammable materials? And it kind of walks you through the process of what steps you need to do to prevent a fire. Fire watch requirements. The fire watch essentially needs to be trained. And we're going to go over some of these things briefly. But his job is, if there's a hot work permit required, you need somebody who, after the hot work is done, to make sure that nothing ignited, or there was a spark that no one noticed that blew around the house back there, or the treater shack, and it's lit the grass on fire. But the welder gets in his truck and drives home because he's good to go, because he's finished, right? And so the fire watch is a 30-minute watch. They're going to walk around, inspect, investigate the area, have fire extinguisher media, and ready to put anything that might have smoldered or ignited unintentionally out. So they need to have fire extinguisher equipment readily available, and they need to be trained in its use. And typically it's a 30-minute wait time after the work is done. So that's a minimum. Sometimes it's longer, but 30 minutes is kind of a minimum. So obviously these guys' job is to keep a diligent watch for fires. Make sure that there's nothing that's going to ignite. If they see something, fix it. Close a valve, spray water on it, put a blanket over it. Whatever you got to do to put it out. So they obviously need to have PPE for that purpose. A lot of times they don't necessarily need to wear respiratory protection, but it's not a bad idea to have an SCBA on hand just in case there's a lot of smoke or something and he's putting that out. You don't want to be breathing in that smoke because of its toxic nature, etc. All right, getting into chemicals a little bit. We're just going to focus on the fire hazard here, but there's a health hazard, fire hazard, reactivity, and that's blue, red, and yellow respectively. And then lastly, in the white, you have specific hazard. So when you see these NFPA levels, it doesn't necessarily just mean, yes, it does mean danger, and the higher the number, the more dangerous, but there's a specific determination of what that number is, and it has to do with flash point, so the temperature at which something will ignite. So if you see a 1, it's going to be essentially above 200 degrees Fahrenheit. So we know it can ignite, but that chemical has to, literally get above 200 degrees in order to ignite, right? So that's a pretty low hazard because you'd have to intentionally be trying to get it above 200. Ambient temperature is not going to be warm enough to ignite it. Then you get up to 2, which is below 200, but above 100. 3 is below 100. That's where we really start to see some higher hazard. Because 100 degrees Fahrenheit, inside of my truck, and not even in the summer, I was in there the other day. It was 40 degrees outside, but I had my heat running, and my iPad got over 100 degrees. It was in the dash, sun was beating on it, heat's going, etc. And it got over 100 degrees. So it's not, and it was 30 degrees outside. It's not implausible that things will hit 100 degrees, especially if they're inside of a tank or something metal. Sun's beating down on it. That's kind of ambient. And then 4 is below 73. So below room temperature, in most of these chemicals that are below room temperature ignition, they're igniting in like below zero temperatures. So gasoline, for example, it could be negative 40 and gasoline's ready to go. It'll ignite. You get static electricity, it's going to catch on fire. So just keep that in mind. All right, that number 4 means something. Anyway, so well site specific, obviously there's a good likelihood that the flare or around the flare, there could be a fire, especially if it gets upset and you send oil to it, wrong valves open for too long or closed for too long. There's a good likelihood around the flare you're going to see a fire. Inside of treaters, not so often, or separators. The fire could happen in there. It'd be unlikely. Most of the stuff in there, isn't an ignition source. But on the back side of the treater or separator, where you have burners, there's a little pilot light in there burning all the time, heating up the tank so that essentially, you get the best separation possible from your oil and your water. So wherever you have a burner and a fire tube, whether it's a freshwater tank or a treater or separator, you have the possibility. So on this picture here on the left, you'll see the burner there that's sticking up, and that's pretty low, and that gets really hot. So even tumbleweeds kind of blowing in there could potentially ignite. So keep that in mind. The wellhead's not usually catching fire. If that were to happen, there'd be some pretty serious issues. But yes, wellheads and can also catch on fire. Anywhere you have potential for release, Vic clamps, ball valves, 90s, unions, anywhere there's a potential for a leak, there's a potential for a fire. So training, if you're expected to put fires out, right? You're they want you to put a fire out. They say, here's your fire extinguisher, be ready. Then you're required to have hands-on training. So this picture here is a class we did a little while back, where we, the top little box that's in the center there, we filled out with fuel, we let it drain down, we light it on fire with a pretty sweet blowtorch gun, flamethrower, and then we light that puppy on fire, and then everybody comes and tries to put it out. And it's actually a lot harder than you would think if you're not doing it the right way. If you do it, we saw guys put this out in like 8 seconds, and we saw someone that used an entire extinguisher and didn't put a dent in it. So it really does, as far as the strategy. So for you watching this training, we do this, and we'd like to do it with your company. So if you're interested, let your supervisors know, and we can come out and actually do a hands-on course, because it's pretty valuable. So you may have fire extinguishers, around and be expected to use it, but definitely recommend, and the standard recommends, that you get some training on how to do that. So inspection of fire extinguishers, there are different inspection frequencies. Some are 5 years, 6 year, and annually every extinguisher needs to be inspected, ensure its weight is correct, ensure the powder isn't, compacted in the bottom of it, etc., as well as making sure that the pin is in place, it's the right pin. I see a lot of, zip ties and like cotter keys in there. That's a no-no. It's got to be an actual fire extinguisher pin. So just keep that in mind. Fire extinguishers, lots of different types, again, for the different types of fires. And usually for us, we're using a dry chemical powder for ABC. That's the most common that we see. So again, water is for type A fires only. CO2 is good for B and C fires. A wet chemical is typically going to be in our K area. And then foam, depending on what we're doing. A and B fires are good with foam. Usually that's what firefighters are using if they use, foam to fight house fires, etc. And then powder is good for your A, B, and C. As far as where the extinguisher goes, both height, where it's positioned, as well as size for what type of building you're in. There's some good information on NFPA's website. I know if you're like me, you don't have any friends or social life on the weekend, so you're just perusing the NFPA website. Really, it's a very exciting Saturday night. But if you are, if you are interested, you can print this free fact sheet off and take a look at it. And basin safety, we do fire extinguisher inspections as well. So typically with our training, we just make sure everything's up to date on your fire extinguishers. So using a fire extinguisher, there's the well-known acronym PASS, which is pull, aim, squeeze, and sweep. So you pull the pin, you aim the wand at the base of the fire, you squeeze the handle, and then you sweep side to side. Now that's not just a really quick sweep. You're actually going to be fighting the fire with each stroke as you move that wand back and forth. So fighting fires in the incipient stage, or the initial stage, is the right time to fight the fire. Once it really starts to get big, and this is another reason why doing the hands-on fire extinguisher training is important, because you get a feel for like how long an extinguisher is going to work for you. And some of these extinguishers stop working after like 10-15 seconds, so you really want to make sure that you're ready to go. So if you're ever concerned about whether or not you can fight that fire, don't. Step out, get away, run. Insurance policies cover damages to equipment. People cannot be replaced, but equipment can be. So whether if it's a truck or a building or a field or a treater, definitely if you see it in an oil and gas facility, your best move is just to run away. All right, so our next topic, emergency response and exit plans. So I've got an example of a production facility emergency action plan. So at a production facility where you got a pumping unit, you got tanks, you got a treater, you got a separator, all that, there are different situations where emergencies might happen, which would require response. So whether it's a fire, if there's lightning, obviously in a fire, in most cases, our responses don't panic and get upwind and away from where you can be impacted by the fire. Lightning, you definitely don't want to be on tanks if there's lightning in quick succession in your area. And then, if there's H2S, again, you want to get upwind, crosswind if your alarm starts going off. If your alarm goes off, it is not a metal detector on a beach in San Andreas where you're looking for gold coins and maybe some treasure a pirate stored there decades ago. You're not looking for the source of the beeping. You want to get upwind, crosswind right away. Then check your monitor, see what's going on, evaluate, and make a decision. So having an emergency action plan for different facilities that you work at, what the plan is, having a plan is extremely important. And a lot of times when situations get worse or become worse than they need to be, it's because people did not go in with a plan. So you want to be prepared. You want to know where your exits are, the fire alarms are, safety equipment, etc., so that if you need it, you naturally go to it because you know where it's at. You've identified it and kind of clicked that in your mind. If you want to learn your building evacuation plan or a site-specific evacuation plan, where the muster points are, know where your nearest exits are or your path to get out of a building or off of a location. Make sure that there's nothing that's blocking your exit, as well as fire extinguisher or safety equipment. You want to know the sound of your building fire alarm, or on a facility, if an alarm is going to go off, what that sound is going to be. Post-emergency numbers, you should have access to the people that you call in the case of an emergency for sure, and then make sure you know what to do if an alarm sounds. You want to make sure your escape is already planned, as well as what you're going to do in reasonably anticipated possibilities for an emergency, right? If there's a fire, again, if there's a storm, what you're going to do, a well control issue, you want to make sure that you're ready. As far as exit routes go, you want to make sure, again, that they're clear. Know your safest route to an exit. 28 inches is kind of the minimum width. So if you're in your shop and you're looking around and be like, is this enough width to get out of here? 28 inches is your typical width, which is also the width of most wheelchairs. So keep that in mind. That's where that comes from. And then there's a few things besides just getting out of the building. There's actually 3 elements to an escape route. The way to get to the exit itself, and then where that exit leads into. If you have an exit that leads directly into a propane tank, that's not a great muster point or exit route. So you want to make sure that all 3 of those elements are taken into account when you're planning, an emergency response. So history, where this all came from. So, if you've been through this training before, I typically bring this up, and this is kind of the first instance of a workplace accident, both involving a fire and really that, really opened the government's eyes to maybe we should have some, now I'm not a big fan of, the federal government telling us, how they're going to help us. But, when it comes to some standards and regulations for best practices, I think it's great. And what happened in 1911 at the Triangle Shirtwaist Factory in New York is there were employees, they were coming in the morning, and then they would leave, they'd clock in, leave, and then come back at the end of the day and clock out. So they're getting paid but not doing anything. So the general manager of the facility had a great idea. Once everyone came in for the morning and clocked in, he'd lock the doors. So you couldn't leave until the end of the day. Well, they believed someone was smoking because they couldn't go outside to smoke, smoked, smoldered in a trash can, lit the building on fire, and everybody expired inside of that building. A lot of people were jumping from the windows, and then people were like, hey, maybe we shouldn't be allowed to just lock people in a building, with flammable combustible material. So that's really where it started, was back in 1911. Present day, a couple years ago in Pakistan, 600 people were injured, 312 people died when a boiler exploded. No emergency exit plan, no plan for what to do. People were just stuck, So it still happens today, unfortunately, without a plan, without thinking through worst case scenarios. These possibilities are very likely. So in a workplace emergency, we've got earthquakes, utility outages, fires. Earthquakes are a really big issue in this area. Even getting down to terrorism, active shooter, stuff like that. It's a good idea to have a plan for worst case scenarios. So in those situations, you're executing strategy rather than responding to panic. And that's really the point of having a good plan. And I recommend it if you don't have it in your company, have one, have an exit plan written out, tell people where to go and how to get there, whether it's on a facility or in your building. So as far as who to call, obviously 911 is kind of the go-to. We're all pretty familiar with that. But depending, if you're out on location, your 911 tower could be in Canada. So just kind of keep that in mind that 911 may not always be the best option. It may be good to have some emergency numbers stored in your phone. So for our company, we have an emergency contact list that has Sydney Fire, Sydney Hospital, Sydney Ambulance, McKenzie County, Watford City Hospital, Ambulance, Fire, Minot, Sydney, already said Sydney, Stanley, all these different towns. So we just have access to those numbers in case the 911 directs us to the wrong place. So OSHA's record keeping and reporting. If somebody goes to the hospital, it needs to be reported to them within 24 hours. If there's a fatality, that needs to be reported within 8. So emergency preparedness, again, knowing the possibility, knowing that an emergency could happen, and then planning for that eventuality is very rarely happens when things get out of control. When accidents happen and then everything from that point gets way worse, it's typically because people we're not prepared. And part of that preparation is training, conducting drills and exercises, and then re-looking at the plan from time to time, reviewing it and making sure that it's accurate. So that's all, part of the emergency preparedness plan. Now, if regulators do show up to your facility, there's enforcement regulators and there's investigative and regulators. And if an enforcement agent does come to your facility, shop, location, rig, whatever, you want to make sure that you shut work down and get an authorized representative of your company there to walk them around. You don't want them just kind of, wandering your site looking for stuff without somebody knowing what they're up to. So just keep that in mind. Make the phone call. You can hold them at the edge of location. Your company may have a specific policy to this, but you can't hold them on the edge of location until they get a warrant or your supervisor gets there, perfectly well within the law. All right, incident command system. Now, this is what we call essentially ICS, and there's different levels of training as well as response. The main one being incident commander, and that's typically a 40 to an 80-hour course to become that. But essentially, when a major catastrophe or incident happens, there's a best practice strategy for handling that and having different roles. So, for example, we have a liaison role here, you'll see in blue, and the incident commander role in green. If the liaison's job is to talk to the media, to the press, to the police, to the the state, spill group, whatever. If you have an incident commander trying to make sure that every element of the response is executed appropriately, and he's over there talking to the police or the feds getting angry, it's going to affect the ability for that response to be done correctly. So you have a liaison for that, and that's his job. You have safety to make sure that everybody's following proper protocols and no one's putting themselves in worse danger, so the incident commander can focus on what he's doing. Then you have operations people, planning people, logistics people, trucks coming in and out, whether it's delivering stuff or taking stuff away. And then lastly, finance administration. So the ICS system is an emergency response best practice system out there. Great training. We offer some of these courses. If you'd like to learn more, you can let us know. All right, again, a little bit more on escape routes, typically more in buildings, on a location. Yes, there's such a thing as escape routes. We typically just think of a path of exit rather than an escape route, because, we're not going to mark the location with yellow paint on, where you're going to go, because the whole thing would be marked up depending on where you're standing. So when there's a door, that's typically where you're going to have escape route. As I mentioned, 28 inches is the width, and ceiling height needs to be at least 7.5 feet on your way out. Locking exits is a no-no. We don't lock our exits, period. We don't want to block our exits either. So we want to make sure that doors in buildings where there's more than 50 people, those doors swing outward rather than inward, obviously, so that people can just, push themselves out and the door is not going to be an obstacle to exit. We don't want to obstruct exits. And then on facilities, here's a picture of a SIMOPS event going on. I think there's 2 fracs at this well site at the same time. I mean, do me a favor here. If you're with me, listening to this, look at this middle picture and put yourself right in the center of all that activity. And someone said, the alarm starts going off. It's time to, get to the muster point. Where do you go and how do you get there? That's not something you want to determine at that moment, because it's likely you're going to go the wrong direction, you're going to get turned around, you're going to go in circles, or you're going to go right into the big pit that, essentially covers the entire north section of that facility, of that site. So knowing that ahead of time, like, hey, kind of keep it in your mind where you're at in reference to the path you're going to take to get away if there's an emergency is vital. Also, in buildings, not blocking, not having materials, etc. in front of the door. You want to get out of there as easily as you can. Exit marking. Exits must be marked. We want to have a sign that's lit up in case there's smoke or fire, so you can actually see the sign in order to get yourself out of there. So keep that in mind. All right, lastly here, just kind of reviewing from the fire extinguisher side. Remember, there's 4, and fire and just in general, the fire science, there's 4 elements that are required for a fire to exist. You have heat, oxygen, fuel, and a chemical chain reaction. So if you can eliminate one of these elements, then that fire will go out. And so a lot of extinguishers are designed to remove typically the chain reaction. Sometimes it's the heat, as in the case of water, but it really, in oxygen in the case of CO2, as well as halon. So just remember, there's different types of extinguishers out there, and they're all their jobs is to eliminate one of those elements. So the 5 different classes of fire, we have A, B, C, D, and K. And each one has its own, again, ash, boiling point, charger current, dent, and kitchen. So that's kind of our quick pneumonic device. Hot work permits, necessary to have one if you're within 35 feet, sometimes up to 50 feet, depending on what it is that you're working around. It's a good idea to move stuff away as far as you can. Use fire blankets. Absolutely, most importantly, when incidents happen and people die from hot work and explosions, 99 out of 100 times, they did not do gas detection first. They didn't verify that there was no level of flammable material. They went to welding or cutting or whatever, and that's when the incidents occur. With hot work, you obviously have to have a fire watch who is there with you completing that. So you want to make sure that there is somebody watching that fire. When you operate an extinguisher, you want to do 4 things. You want to pull the pin, aim and squeeze at the base, sweep side to side, or squeeze and then sweep side to side. So PASS, pass, pull, aim, squeeze, sweep. Lastly, having an emergency plan, whether it's on a facility, on a frac site, on a drilling site, during workover operations, or in your building, is highly recommended, required by the law, and just a good idea. If again, you don't want to find yourself in a situation where after something happens, you're both panicking and trying to figure out the next best step. And making the wrong decision in an emergency situation can cause more damage and put more people at risk, as well as yourself, which if you get in trouble and go down or get hurt, someone's got to come rescue you. So if that hazard still exists, you're actually putting other people in harm's way. So think ahead. Think of worst case scenarios, document them, work with your supervisors or our team. We can work with you as well to make sure that there's a plan in case something goes wrong. So with that, that's it for this month's training. Thank you very much. Remember, take the quiz. One other thing I want to mention too is we are about ready to draw for our shotgun this spring here. So I guess end of winter, early spring. So put your review into Google or Facebook, LinkedIn. There's probably some other ones, but if you go in there, find base and safety, put it in, you're automatically entered into the drawing. We'd love to see your review, see how we do. Have a great month, and we'll see you in March.